What is going on, students? We're going to do the 5-7 notes here really quick. I would like you to start on page 336 to 339. Go ahead and do a little vocab hunt. Scatter plot, positive correlation, negative correlation. Oop, that didn't copy very good. I forgot to fix that when I brought it out. Yep, you know what? Fill that in too. No correlation, a trend line, interpolation, extrapolation, and line of best fit. All right, so first of all, let's start about describing correlations. Is it positive or negative? Basically, what it's asking is something happening mathematically to these numbers on a scatter plot, these data points on a scatter plot. So what is a scatter plot? A whole bunch of dots of random information. So let's see here. What's happening? As we're going this way, as x is increasing, it looks like the y values are going down. So what do you think is going on there? I'm guessing some type of negative correlation is going on. As x increases, you're losing things overall. That's the general pattern. This one is all over the place. So yeah, no correlation. I can't tell. It's all over the place. Oh, this one's going up. Positive. Okay, don't think too hard, friends. This one kind of horseshoes. It goes up and it goes down. If it goes up and it goes down, there might be some type of math situation going on there, but we're talking about just linear situations right now. So in this case, positive or negative, I don't know. So I'm going to go ahead and say none. All right, so positive or negative correlations are easy to spot. None are also very easy to spot. If you can't even tell, it's safe to just say none. Now, you can make a line of best fit by hand. It's not the most accurate way, but you can do this stuff by hand. So what do you mean? You want to try to make a line that's going to generalize the pattern here. So what you want to do is you kind of want to chop the data in half, where half of your values are on one side, half are on the other. That's pretty good right there. And then the second part is you kind of want to hit at least 2 points along the way. So, ooh, that's actually a nice fit right there. Look at that. I hit 4 data points right there. And then I have some on the bottom. I have some on the top. So I'm just going to go run with it, okay? Again, when you're doing this by hand, you're kind of estimating, okay? So, boom. That's what I think the line of best fit is, approximately. So what am I going to do? I'm going to use a couple of coordinate points. I'm going to use the first one I hit over here and the last one I hit. So I'm going to use those coordinate points to actually make the equation. So if these were just regular, I'm guessing they're regular coordinate points. Maybe it'd be nice if I had a label here. So this one is 1 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wasn't that nice? This dude is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 3. Okay. So I've got to myself 2 coordinate points. How do I make the equation? I got to make one of these. Y equals mx plus b. So I probably want to find the slope first. Let's see. Change of y over change of x. Change of y over change of x. The y value goes down 7, and the x value increases 10. Okay, there we go. So my equation is going to be y equals negative 7/10 x. Now, since I estimated, I probably, if I wanted to cheat here, I could totally just kind of estimate my y-intercept here. So this is 10, and that's 11. Maybe 10.8. Okay. I mean, I'm going to go, why not? I made that by hand, so why can't I just kind of eyeball the y-intercept right there? So I think the y-intercept's about 10.8. Now I could, if I wanted to be more official, I could actually plug in an x and y value and solve for that. Okay, so how about I just pick, 1 and 10, okay? So if I wanted to, I could go 10 is going to equal negative 7/10 times 1 plus b. Remember the shortcut, b is always going to be y minus mx. So let's go plus, see, 7/10 times 1 is just negative 7/10. So to get rid of a positive 7/10, I add 7/10 to both sides. Hey, what do you know? I was close. 10 plus 7/10 is 10.7. Hey, look at that. Really close. Good job, me. So my guesstimation and my math were pretty darn close. That's the whole point of guessing, drawing, sketching a line of best fit, is just to guess the best you can. Okay, so, oh, by the way, type of correlation, negative. Oh, weird, my slope was negative. Crazy, right? Okay, moving on. Let's see here. We got another one. Looks like we have some type of positive correlation. Data's kind of going up this way. Let's kind of chop half of the coordinate points. Ooh, could I really be that lazy? Could I be that lazy? Could I have it go through the 0, 0 and have a slope of nada? I think I can. Don't judge me. As long as I hit one coordinate point, I'm going to hit that one right there. Hit a couple, 1, 2, 3. Yeah, it's a little bit, yeah, but kind of balances out. These ones are kind of off the line, but this was this one, so it kind of balances out. So let's pick quarter point and hit best. I hit this one. Ugh, not really had a grid point. I almost kind of hit this one right here. Over 1, up 2, over 1, up 2, up 2. See, I almost could call it a slope of 2. I'm just going to go y equals maybe like 2.2x, roughly. Okay, over 1, up 2, a little higher. Over 1, up, there you go. It's over 2.2. Yeah, I don't know, man. It's kind of all over the place. And ooh, that brings up a fun fact here. Even if I don't hit a data point, I could kind of use this to make my own slope if you wanted to. So my y-intercept is 0. Let's see, rise over 1. It goes up 1, 2, 3, 4, 5, 6, 7. Double check that. 1, 2, 3, 4, 5, 6, 7. It goes up 7, over 3. So rise over 1, 7 thirds. Y could be 7 thirds x. Okay, again, I'm estimating. And I cheated a little bit. I went through the origin to save myself some y-intercept headaches. So there you go. It's about the same thing. Isn't that just like 2.3 repeating? There you go. So you can kind of see there's a weakness here besides, well, I can't even talk. There's kind of a weakness here doing it by hand, is that you are off by not a ton of data, but you're not exactly very accurate. So on the back page, we'll talk about how to do things super duper crazy accurate.